What you see here is an important device. We call it a capacitor. It's two parallel plates that have electric charge on them, one positive and one negative. They're important because they're used in a lot of devices, in everything from camera flashes to defibrillators. But for us now, they're important because of the electric field that they create. In a parallel plate capacitor, where the plates are fairly near each other, you can see that the field lines near the center are straight and equally spaced. This means that the field strength has a constant value. We call it a uniform field, and for all problems where we want the electric field to have just a single value, this is how that electric field would be made. We finish this lecture with one final thing about electric fields. All of the fields we've shown so far have been in air, but what would the electric field look like inside a conductor? If we put a conductor whose electrons are free to move inside a uniform electric field, then the electrons will feel a force opposite to the field. So they'll move to the left-hand side of the conductor and congregate there. That means that the left-hand side of the conductor becomes negative and the other side positive. This will create a little bit of field inside the conductor that will cancel out the external field. So on the whole, there will be zero net field inside the conductor. This is always true for any conducting shell. The electrons will always move until they reach equilibrium, where they've created a field that exactly cancels out the external field. This is the basis of the Faraday cage, where you have a shell made of metal, and it doesn't have to be solid, even mesh or wire will do. You can see some amazing demonstrations on YouTube of people protecting themselves from very high voltages, where you have sparks like you can see there. The cage protects them by cancelling out the electric field and leaving zero field inside. In the example on the left there, you can see that we have a microwave door with mesh behind the glass. In this case, the electric field is inside the cage, but there's zero field outside so that you're protected.